here's our objective, and there are really going to be three factors that we want to explain. Uh, in this video, there's a fourth factor, but in this video, we're going to talk about concentration, temperature, and surface area, and all of them affect it in a similar way. Basically, they're all going to increase the collisions that are happening, and therefore they're going to increase the rate. They're also, temperature is also going to increase the force of these collisions, and therefore the rate as well. There is one other factor that this video doesn't deal with, that's activation energy. That does it in a little bit of a different rate way, a little different rate. All right. Here's the collision theory. This is what it's rooted in. All right. Now, the first one I want to talk about or show you is concentration. Now, all right, this video is of magnesium reacting with hydrochloric acid. And here's the magnesium, you can see it. This is 1 molar, and this is 6 molar hydrochloric acid. And you're going to hear a that's the magnesium on the right. Look at all that froth that's given off. It's reacting a lot more vigorously. Now, I'm going to explain this with shapes as well. Here's the equation I want you to have for the shapes. All right, a circle, two circles come together. When concentration goes up, what's going to happen? Well, the molecules are going to hit more, therefore they're going to react more. It's because they're in closer proximity. All right, therefore that's how they're going to affect the rate, why they're going to affect the rate. Now, there's another visual that I'd like to show you. This has to do with gases. This is changing the volume. If you shrink the volume, you're going to do the same kind of thing. You're going to make them come together more and react more. All right? It's as simple as that. Just because they're going to be able to hit each other more. All right? Now, temperature. I've got a couple videos for you. Temperature has a similar relationship in that when you increase the temperature, you increase the reaction. You're causing more collisions and with more energy. This is the Mentos and this is a cold water one. You can see it there, it's going to froth some. All right. This one, now you can already see this is room temperature. You already see it's like going there. There it's going to go. There it goes. All right. And this one is the hot water bath. I heated up some water, boiling water, and then put the Diet Coke in it. Was a little nervous it was going to like pop on me. It didn't, as you can see. And here we go. I dropped the Mentos, and here we go. Yeah, you can see it shot up about a little bit over 2 feet, goes a little higher, and it's done. It's pretty cool how it's like boom, bang, boom, done. All right. Now, this was an experiment in lab. It's going to show the same relation. This is some hydrochloric acid in a cold water bath. Temperature was about 0. And then I took some and brought it up to about 180 degrees or about 90 degrees Celsius and warmed it up. All right. And then I put them both on a test tube rack in the fume hood, and then I reacted them with magnesium. Now you can see on the right, this one's obviously, or not obviously, is reacting more. Now, if you listen quietly, when I drop the piece on the one on the cold water, you can hear it's just a little, and then the big piece in, it goes, it really hisses. That's because the warmer the acid, the more it's going to be moving around and the more it's going to hit it. No, I didn't bring it back far enough. See, there it is. That's a much stronger reaction. All right. Now, here is the visual for temperature. All right. And a great way to show that these things are moving around is just simply with arrows. And the bigger the arrow, the bolder the arrow, the faster the molecules are moving. Therefore, they're going to collide more. And the force of these collisions will be greater. All right, and that's how it's going to make the rate go up. All right, surface area. Now for surface area, what I did is I started with some magnesium, cut it up into little bits. All right, put it in a microwave plate. This is calcium carbonate. I took that, crushed one of them up, and put it in a powder form. All right, and then I reacted both of these with hydrochloric acid. And you can see which ones are reacting, the ones with the larger surface area. All right, you can see the froths. You can't even see them there, and then here it's like a lot more reactive. Um, one, don't be deceived on the one on the right. It's reacting all the powders on the bottom, so it's reacting so much that the powder is kind of being like, and then the bubbles are a little discernible, unlike this. All right. Now here's a visual for surface area. And this is for solids reacting with a gas or a liquid, and it's typically, you think of it like a chunk. All right, if you keep the chunk together, it can't hit the molecules you want it to react it with, and if it becomes a powder, you really free it up to react and interact. Therefore, you're going to see this kind of relationship. All right, now catalysts, they lower the activation energy. We'll do that in a separate video. All right, thank you and have a good night.